In the last video, I had you learn how to name ionic compounds, both binary and ternary ionic compounds. And you probably heard me say it more often than you wanted to hear it. Leave a space between the two elements, or the two names, the metal and the polyatomic, so that you have room to go back and put a Roman numeral. Now in this video I'm going to show you which ones need Roman numerals and how to add the Roman numeral, the correct Roman numeral. Figure out what number the Roman numeral needs to be. So the reason you need Roman numerals is because some of the elements can have several oxidation states, and there's nothing in the name that indicates which oxidation state you're working with. So it's important to add Roman numerals to make sure that you give someone all the information they need to write out the ionic formula, which ionic compound you're working with. So the Roman numerals tell you what the oxidation number of the metal is. So indicate the oxidation number of the metal. So if you have a Roman numeral 2, that means that the charge on the metal is a +2. If you have a Roman numeral 4, that means the charge on the metal is a +4. And the metal will always be a positive charge. So the Roman numeral is equal to the charge, which will be a positive charge. And you only use Roman numerals for metals that can have more than one oxidation number. In class, I will show you exactly which ones need it and which ones don't. But for now, I'm going to give you this example. We've got FeCl3 and FeCl2. And then here's the little snippet of your yellow sheet so that you can see iron down here. Iron has a +2 or a +3 charge. Now, if I were naming these two compounds according to the rules, they're both binary, so I'd go B and B. I'd say, okay, this is iron, and then Cl is chloride. Okay, this one's also iron, chloride. Because remember, it doesn't matter if there's 3 of these or 2 of these. I don't use prefixes or anything like that. So both of these would be called iron chloride. And we actually have both of these in the stock room, FeCl3 and FeCl2. They're both back there. So let's say I ask someone, hey, can you go grab the iron chloride? They'd go back there and they'd see on the shelf that they're right next to each other even. That both of these, they'd see both of these and they'd come back and say, well, which iron chloride do you want? Do you want the FeCl3 or the FeCl2? And that's when I'd have to be more specific. So instead of having them come back and I'd be like, oh yeah, the FeCl3 or the FeCl2, I could give them all the information they need the first time by putting Roman numerals in here. So we put parentheses and we're going to add Roman numerals in here to specify which iron chloride we're talking about. So in this case, if I'm looking up oxidation numbers, chlorine has an oxidation number of -1. If there's 3 of them, 3 -1s is going to be balanced out with a +3. So this +3 charge is balanced out with these 3 -1 charges. This one only has, chlorine still has a -1, but there's only 2 of them, so this iron is only a +2 charge. So the first thing we need to do to figure out what Roman numerals go in here is figure out what is the charge on the iron. Remember, iron can be +2 or +3, so we're going to put Roman numerals in here that tell me which one we're working with. In this case, I'm working with iron with a +3 charge, so I'd put Roman numeral 3 in here. In this case, I'm working with iron with a +2 charge, so I'd put a Roman numeral 2 in there. So now if I told you, hey, go back and get some iron 3 chloride out of the stock room and bring it out, please, you'd go in and say, okay, iron 3 chloride, that's FeCl3. Or if I said, go get some iron 2 chloride, you go get FeCl2. So now we have enough information to distinguish these two compounds only using their name. And if you're not sure what the Roman numerals are, you might want to write these down. 1 is an I, 2 is basically 2 I's, 3 is 3 I's, 4, the letter I, 4 is IV, and then 5 is just a V. So those are the first 5 numbers, and that should be all you need for this class. So examples. We've got CuOH2. First thing I'd do is I'd name it copper. Oops. Copper, and then OH is hydroxide. Copper hydroxide. Now I'd look copper, or is it on my yellow sheet here? It can be a +1 or a +2 charge. So I need to figure out which one it is in this case so that I can put my Roman numerals. So I see that copper can have two different charges. Copper can have two different charges. So I have to say, is it copper 1 hydroxide or copper 2 hydroxide? So the next thing I do is I say, okay, I've got OH, which is a -1 charge, and I've got two of them. So I've got two -1s, so it must be balanced out with a +2 charge. So in this case, I'm working with the copper with a +2 charge, so I put copper 2 hydroxide. The next one, I get mercury, also hydroxide. That's a messy word there. There you go, messy handwriting. In this case, hydroxide's still a -1. I've got two of them, so mercury must be a +2 charge. And also, I check on my yellow sheet. Mercury can also be a +1 or a +2 charge. It has multiple options. So in this case, I'd say, okay, this is mercury 2 hydroxide. And the Roman numerals go between the names. Another common mistake I see is that students put the Roman numerals at the end of the name. I'm not sure why they do that, but that is not correct. And then the last example here, silver phosphate. So Ag is silver. PO4 is phosphate. And in this case, phosphate is a -3. There's no parentheses, so -3 times one of them is -3. That means this side has to be a... nope, doesn't like me writing over here. That means this side has to be a +3. Now there's 3 of them, so those 3 silvers add up to a +3. That means each silver itself is a +1. So don't forget your oxidation, how that works. And actually, if you look up silver, silver can only be a +1. So I actually did all that work for nothing. I just wanted to do it to refresh your skills on oxidation numbers, how to calculate it around to silver. Because silver is only a +1 and it's never anything other than a +1, I would not put Roman numerals here. So I just leave it as silver phosphate without Roman numerals, and it will be marked wrong if you do put Roman numerals when they're not needed. So make sure you only put them when they're needed. So a couple just things to remind you. You only potentially put Roman numerals for the first element if it is a metal. You never do it if it's a polyatomic like ammonium. So if it's a ionic compound and the first element is a metal and it has more than one oxidation number, you use Roman numerals. So it has to meet all of those requirements. It's got to be ionic compound, a metal, and that metal has to have more than one oxidation state on your yellow sheet, then you put Roman numerals. If you answer no to any of those questions, do not put a Roman numeral in there. If it only has one oxidation state, don't put a Roman numeral. If it's ammonium, if it's not a metal, don't put a Roman numeral in there. So be selective about when you use those. So things like silver, zinc, they are transition elements, but they only have one oxidation state. So don't put Roman numerals in for those.